Hello, everybody, and welcome to Mr. Saucedo's YouTube videos. Today, we're going to be talking about properties of water. So, why is water important? There are many reasons, right? But water, aka H2O, is basically essential for life. And so, do you know what percentage of the human body is approximately made up of water? It's about 72%. But based on different organ systems and different organs, that either is greater than 72 or less than 72. So, like, you probably could guess, right, that your blood is mostly made of water. But what about your muscles and your bones and your brain? So, the breakdown ends up being something more like this. So, the brain is 80.5% water, more water than the average, right? Bone only 13%, right? That kind of makes sense. It is a very hard, solid substance. Blood 90.7%, muscles about 75.6, kidney 82.7%, right? And that's part of the excretory system, which is, used to excrete urine. So makes sense. Now, what's the purpose of us talking about water and why it's so special? Well, there's some things that you need to know about water that lead us to the conclusion that it is essential for life. So, first of all, water is a polar molecule. So when we say polar, what we mean is that it is slightly charged. So you can see, right, that H2O is made up of two hydrogens. They're located as those like kind of Mickey Mouse ears at the top, and they're kind of like whitish gray. And then you have a Mickey face that is literally just that big red oxygen. And so the hydrogens have a partial positive charge. The oxygen in the center has a partial negative charge. And how do we distinguish between partial positive and negative? So we know positive is a plus, negative is a minus, but we're not talking about full-on charges. We're talking about partial charges. So we use the two symbols that you can see right there. It's a little lowercase delta symbol, so delta positive or delta negative. And so I'm going to label that, and you should probably also label it in your notes. So we've got delta positive up at the top where the hydrogens are, delta negative where the oxygen is in the center. All right, now, what's important is that H2O forms what we call hydrogen bonds. So hydrogen bonds are what form between hydrogen, go figure, and partially negative atoms like oxygen, go figure, right? We got H2O, we've got hydrogens and oxygens. Of course, we're going to form some hydrogen bonds then. And then you could also form that between hydrogen and fluorine or hydrogen and nitrogen. Oxygen, fluorine, and nitrogen are those like really partially negative electronegative atoms. Now, hydrogen bonding is a strong force and it is an intermolecular force. So we're not talking about like you probably remember learning, I don't know when, but in eighth grade maybe, ionic bonds, and covalent bonds and all that stuff. No, we're talking about intermolecular forces, right? And so these intermolecular forces are what give enzymes their shape, right? Which are extremely important, and then DNA. And so here's what hydrogen bonding looks like. So you can see what we have here is hydrogen, and it is going to, because it's partially negative, it's going to be attracted to the partially negative oxygen of another water molecule. And so that dashed line is a hydrogen bond. It's supposed to represent a hydrogen bond. And so the reason why hydrogen bonding is important is because it holds things together. And so what's one of the most important things? DNA. And so you can see here we have these little dashed lines here. These are hydrogen bonds holding together the adenine and the thymine, and then right here holding together the guanine to the cytosine. So that like twisted ladder shape wouldn't exist unless hydrogen bonding were a thing. Now, what is hydrogen bonding responsible for? Well, it's responsible for many features that water has, but we're going to focus on three really important properties. The first is a high heat capacity. That means it takes a lot of energy to heat up H2O, right? And so that's why we use it, to cool things off in like the radiator of a car or like in an engine or whatever, right? We use water to cool things off because it is so good at absorbing large amounts of heat. Why is that unusual? Because substances that don't have hydrogen bonding normally do not have very high boiling points. And because, the Earth's surface, it's never going to get hot enough for water to boil. That's really important. But if we had something that had a weaker intermolecular force, it's possible that we would never be able to have liquid. in the same form that we would if we, like for water. So if it was methane or something, that has a very weak intermolecular force that doesn't have hydrogen bonding. And so if you had methane on Earth with our temperature, it would just be a gas. We wouldn't have any liquid at all. Cohesion. Cohesion is the attraction between molecules of the same substance. And so it is the reason why water forms these cool little droplets. So water forms droplets specifically because hydrogen bonding is literally holding the water droplet together. Adhesion. Adhesion is attraction between molecules of different substances. You've probably seen this before with using like a tape dispenser. Obviously, tape is attracted to itself. That would be cohesion. But it also is attracted to paper. So if you put a piece of tape close enough to the surface of a piece of paper, it will automatically adhere to it. And so that would be, again, attraction between different substances. Also, it's the reason why if you dip a straw in a liquid like water, the water will travel up the inside of the straw a little bit. There are plenty of examples of adhesive forces, right? You've got water bugs and you've got gecko feet, things like that. And so, last but not least, often mixing a nonpolar substance with water can cause hydrogen bonds to break. So, by adding soap or adding oil or adding, something that is nonpolar, which, by the way, just means, it does not have a partial charge to it, you end up weakening the properties of water. And so, again, mixing oil and water or soap and water and something together like that, if you were to shake it around a little bit, normally that would weaken the properties the water has. And that's it. So if you have any questions, please let me know.